Howdy, y'all. Okay, so back at it. I'm gonna repeat some of the stuff because maybe you didn't watch both videos. So you pop open. This is quiz 1.1, but I should be on quiz 1.2 actually. So let me go to 1.2. Um, so you pop open the quiz, and the graphic's so small you can't even see it, right? So you make this disappear, right? So that's the first thing. And then this thing you can get smaller as well to give myself more screen space. So I'm going to go a couple control minus when I'm clicking on the URL, right? So click on the URL, control minus, and it makes it bigger. Okay, so let's do a couple of these. I think this is the harder of the two, if I'm thinking correctly. A lost chicken trying to cross the street. So he's going back and forth. He's lost. And so what's the displacement from 2 to 4 seconds? So we're going displacement from 2 to seconds. And I got it my pen there. From 2 seconds to 4 seconds. And that's a real good one. I'm going to actually see if I can um, take a kind of a snapshot of this and bring it over to the other program here. Control V. I'm going to crop that. I'm gonna make this a little bigger here. Okay. All right. So we can see it a little better. So displacement on a VT graph. You got to remember on a VT graph, displacement is delta x. So delta x really is defined as delta x is really um, defined as a couple ways. XF minus xi. But that's on an x graph, right? I mean, that you can't actually see position here. When you're on these, your displacement is going to be your area. So we have this idea. If you remember, we say okay, x VA, and in my slope of my x will give me my v, and my slope of my v will give me my a. This is our memory thing, our mnemonic device in some ways. And then our area of our a gives us our v, and our area of our v gives us our x. And so, how are we gonna get x from a VT graph? We're going to use the area, and that's how we get our displacement, right? And so, what is the area talking about? So, really, between 2 and 4, the area is going to go to here. And so, I have two shapes actually. I have a I have a rectangle and I have a triangle. And we have this idea: rectangle is base times height, and a triangle is base times height divided by 2. And so we're just going to add this area. You're literally just going to add this area to this area. And we don't care about anything else on there. I don't care about anything here. I don't care about anything here. I'm just worried about that right there. And so when we add this base times height divided by 2, remember from 2 to 3, this side is 1. I can actually zoom in on this spot now, so we can kind of look. This spot right here, I'm going to make a thicker pen maybe, or maybe I'll change the color. Let's go purple. This side is 1. That side is 1, right? And this height is a -5, and that's important. What's 1 times -5? 1 times -5 is a -5, but it's only half of it. So this is a -2.5. That's what this area is. Now, if we look at this, this is 1 times a -5. So that is a -5. It's just the area. 1 times a -5. So what is my total? My total is a -7.5 meters. Why is it meters? Because this is 1 second times meters per second. And so when we do that, if we get seconds times meters per second, right, that cancels that and you get meters, right? So that's why it works. That's why area works. And so anyways, let me go back to the quiz and see if I can get a couple here. So that one you would put in what, -7.5 or whatever, and then meters, and then you check it. Okay. This one, ostrich accelerates. Ostrich is an average acceleration. So average acceleration, remember, is slope. It's between 9 and 18. And this is a trick question because there's no slope there. It's not changing velocity, so its average acceleration should be 0, right? So it's back to that mnemonic device. It's not area, it's slope. And so that little device that we were trying to use to say, okay, this here, it's both slope and area. You got to remember that and how it's used. Okay, let's go to this next one. David drives and slows. So you got to be careful about this. David drives and slows to a stop. A lot of people getting mixed up with this because the slope of this is one thing, but whatever. I'm not sure what this question is asking, but people get mixed up with this. Average acceleration from 10 to 20 seconds. So from 10 to 20 seconds, and yeah, it's just the slope of that. That's pretty easy. So we're going down 20, but then over 10, not over 20. We're going from here to here. And so down 20, negative 20 over 10, negative 20 over 10. You put your answer right there. Boom. Okay, let's see if I can get a harder one. Eagle is flying 1 to 4 seconds. That's probably a good one. So 1 to 4 seconds. Let's take a look at that. It's a good basic one on that. So I'm going to take a little screenshot of this. I'm going to go over so I can write on it better. And I'm going to go Control V and I'm going to crop this. And then I'm going to look in here. Yeah, let me get rid of my old stuff so you don't see it. So there we go. Okay, so let's Control V. I'm going to crop it. There we go. Crop. Okay, I'm going to zoom in. Okay, Eagle's displacement from 1 to 4 seconds. And so, okay, so Eagle's displacement from 1 to 4 seconds. So this is my pen tool right here. And I'm going displacement from here to 4 seconds. So I'm going to go to here. And remember, this is velocity. You can't just go like, oh, I went 4 because you didn't go 4. This is a velocity. So remember, from our XVA, right? If I'm going down, I'm using slope. And if I'm going back up, I'm using area. And so displacement, so I'm going from V to A. I'm going V to A. I'm going that direction. Let's go to purple here for a second. I'm going from V to A. V to A. So I need to use area, right? So the area of this is pretty easy. It's actually a triangle and a square, just like we did before, right? So base times height, right, is we got, this is actually 1 to 3, which is actually this distance is 2, and this height is 4. The height is 4. And so I got 1 times 4 is 4, and then I got 2 times 4 is 4 divided by 2. No, 2 times 4 is 8 divided by 2 is also 4. So my total of this is 8 meters, and it's positive because it's in the positive side of the graph. Okay, it's not too hard. You're just getting the idea of how this works. Let's look at another one. I want to get one that's kind of pieces. What's the rabbit's displacement from t0 to 3 seconds? 0 to 3 seconds. This is a good one. So this one's showing you both, actually, positives and negatives, right? So I got this rabbit, and same idea. Go back here. I'm going to zoom out a little bit. Control V. I'm going to crop that, and I'm going to zoom in a little bit. So this one's nice because it's positives and negatives, right? So it's another good example of what's going on. So we're going from 0 seconds, and we're going to go to 3 seconds. And so there's a couple ways I can do this. I could do this as one triangle, which is 5 by 2 and divided by 2. So 5 by 2 is 10, right? So it's going up 5, over 2 is 10, and 10 divided by 2 is 5. So this area here is going to be 5, right? But I also could do this, I'll go back to purple, is half, right? So if I just did this triangle, right, that triangle is 1 times 5 is 5, divided by 2 is 2.5. But there's 2 of them. And so either way, no matter how you do it as one triangle, 2 triangles, this area here, is going to be 5 meters. It's either going to be 2.5 plus 2.5 for 2 triangles, or it's going to be 10 divided by 2. Okay, the nice thing about doing the 2.5 is really because you can see that this is the same size, right? If this is 2.5 and this is 2.5, this is also 2.5, but it's not 2.5 positive. It's 2.5 negative, right? So you got a positive 5, and then you're going to add it to a negative 2.5. And so that's really how you got it. I got, but really another way to look at it is like, this thing is going to cancel this thing. So what are you left with? You're left with a positive 2.5 meters. And so really we're just adding and subtracting triangles. If it's anything above is a positive displacement, anything below is a negative displacement, and you just add them. Just make sure you're taking the sum of a positive and negative. You're actually subtracting them, right? So it's the same idea. Okay, a couple more here. I don't want to take too much time, but you can ask me questions specifically, and I can answer your questions. This will give a lot of people a lot of trouble. Because everybody's like looking at this and going, okay, I know that the slope of this is the acceleration, and the slope is 20, a positive 20. It is. It's a positive 20 over 10. So my slope is actually a positive 20 over 10, gives me a positive 2 is my slope, right? And so if we look over here, um, is this a different one I'm thinking of? This might be a different one. Positive 2 over 10. Yeah, okay. So this one is actually this one because it's constant. Now it is constantly accelerating. This is actually not the one I was thinking of that people were having trouble with. But this is a constant positive acceleration because it's a straight line, and so the acceleration is not accelerating. The car is accelerating, but the car has a constant acceleration of 2. Let me see if I can find the other one. Um, Scroll's average acceleration, and it's just the slope. And let's see. I don't think I'm going to get it. I think this is the one. A car driving east slows to a stop. Well, east is that way. That's positive. Okay. Slows to a stop. And it says which is the acceleration. So acceleration is going to be a negative 3 over 10. So that's a point. You can't really see it, but that's a 0.3 right there. And it's constant. So anyway, that's that one. What's the one? Speeds up to the left, right? This is a velocity time graph. Um, um, Blocks motion. Yeah, I don't know. I'm trying to find the one that people were struggling with. I like this one. Average acceleration from 0 to 9, right? Even though there's two slopes here, there really is only one slope, right? Um, it's the overall slope. And so the average acceleration is just the overall slope between those 2 points. This middle point doesn't really matter too much. It'll be an average slope. All right, I'm going to do the same thing I did last in my other quiz. I'm going to actually just see if I can get that hard question, which just shows you that not all the questions are not all the quizzes are the same, and so some quizzes are actually harder than others. And just once again, you notice I didn't answer any of these, and it's kind of complaining like, hey, you didn't answer any questions. And oftentimes, if you're making mistakes, this is something you can do. It's just like literally finish the quiz, submit it, finish the review, and then it's going to ask you if you want to reattempt the quiz. Mine doesn't say that. Mine says preview the quiz. You're just going to go reattempt. And I'm giving you your highest score. It's not an average, so just go for it like that. All right, I'm trying to find. This is the one. This is the one. Okay, this is the one. Awesome. So car is driving west as it slows to a stop, and a lot of people weren't reading these. And the reason they weren't reading these because on the previous quiz you didn't have to. On the previous quiz you only had to read this. But on this quiz, you have to because an acceleration time graph doesn't tell you which direction you're going. It has nothing to do with direction at the beginning, and you need to know your initial velocity, which I could write as vi. I also could write it as what just happened? Oh, I can't do that. I also could write it as vo, right? So initial velocities. It doesn't tell me. So I kind of hard to answer the question if I don't know what the initial velocity is. So I do know that the acceleration is 2 meters per second per second. So I know that if I do a velocity time graph, I'm going to have a slope of 2. It's going to be upward with a plus 2 slope, right? So look down here, and I'm like, boom, must be B, right? Because that's the one. That's right, 20 over 10. That's a plus 2. Bingo, and you get a big red X. And the reason why is because you didn't read. It says it slows to a stop. It slows to a stop, and it's driving west. West is actually to the left, right? Which technically is negative, right? So as you go down here, it was going a negative 20, and then it slows down to a 0, and it stops. And so that one caught a lot of people. So anyway, that's the right answer. Same slope, right? But you same slope, so be careful. It's not just the slope. It's also where you start and where you finish. Sometimes we just pick the one that looks visually easiest. Okay, peacock flying around, displacement from 2 to 3 seconds. That's a good one because that's a triangle and a square, right? It's actually a triangle here. So find the area of that triangle right there and add it, like literally just add it to the area of this square right there, right? I'm drawing with the mouse, which is not as good as my stylus. So you're just adding those two, right? You're adding a rectangle and a triangle. You add them up. It's positive, right? It gives you the right answer. Okay, let's see this one. Hummingbird 3 to 3.5. It's a very small rectangle. So find the area of that rectangle. Jumpy squirrel 1 to 2 seconds. That's just a positive triangle. Let's see. All right, so 2 to 4 seconds. 2 to 4. That's a good one, right? That's a good one because that's multiple shapes. Let's take a look at that. Let's take a look at that one real quick. So hummingbird displacement. Okay, I won't do too many more of these. Actually, let me zoom out so I can see what I'm doing. Control V, crop that out. Okay, so this one, it's multiple shapes, right? So this one from 2 to 4 seconds, and there's 4 seconds right there, and there's 2 seconds right there. So I have multiple shapes. I have a triangle here. So I got to just look at that triangle, find the area, and then I have a big rectangle here and a smaller rectangle there. And they're all positive. So you're literally just adding up this plus this plus this, right? So 4 times 1 is 4. That's an easy one. And this would also be 4 if it was going all the way out, right? So if this is true, that must be 2. And if this is 2, then that must be 1. So that must be 7 meters, right? Hopefully that works. I don't know. So, all right. So anyway, yeah, that's enough. I mean, ask me a question if you have some more questions. But yeah, I remember there was one more hard one. Something about, uh, no, that was the first quiz, I think. Something about ending up the same spot you started. That's a hard one. I wonder if I wonder where that is. That was a hard question. I admit. Okay. Anyway, let me know if you have any questions.